found yourself, staring down some complex tech challenge like managing distributed applications
hmm
and just wishing someone could just sort of distill the key info, maybe give you the surprising bits, and just help cut through all the
Yeah,
noise?
that feeling of needing to be well-informed, but fast.
Exactly. Well, today we're doing just that. We're taking a deep dive into the fascinating world of container orchestration,
Okay.
and we're really zeroing in on two of the big players, Kubernetes and Docker Swarm.
Right. The main contenders for many.
And our insights today, they're primarily drawn from excerpts from Kubernetes versus Docker Swarm, a comparative study by Angela from Sunshine Digital Services.
Okay, got it. And our mission for you, the listener, is really to provide a shortcut, a way to get truly well-informed on this pretty critical DevOps topic.
Right.
We want to help you grasp the core differences, the architecture, the practical trade-offs, and figure out the ideal use cases for each tool.
So you can actually make a decision.
Exactly. Whether you're making strategic calls for production, maybe wrestling with a complex academic project, or even just expanding your understanding of scalable systems. This deep dive, it's designed to give you those essential nuggets of knowledge.
Okay, great. So let's unpack this a bit. Container orchestration. Many of us get containers themselves, right?
Yeah, the basic idea.
But when you add orchestration to the mix, especially for those maybe navigating distributed systems, what exactly are we talking about automating here?
Well, at its heart, container orchestration is really the automation layer for all those containerized applications you're running.
Okay.
It's handling things like deployment, the networking between containers, scaling them up or down, and critically ensuring they stay available, all across a cluster of machines.
So it's like the manager for all the containers?
Kind of. Think of it maybe as the meticulous conductor of a huge dynamic orchestra. It ensures every instrument, every container is playing its part perfectly, at scale, and ideally without needing constant manual poking.
Right, without someone having to run around tweaking things. And that at-scale point feels really crucial, doesn't it?
Absolutely.
Because, in smaller setups, maybe just a few containers, you might just manage them manually.
You could try.
But the moment you scale up, beyond just a handful, that approach just completely falls apart.
It becomes totally untenable.
Yeah.
Exactly.
Yeah.
Manual management gets incredibly inefficient. It's prone to error, especially in large dynamic environments.
Yeah, I can imagine.
I mean, picture trying to monitor, restart, update, or even load balance hundreds, maybe thousands of container instances across multiple servers, all by hand.
Oh, wow. No.
It's just not feasible. And that's precisely why orchestration tools like Kubernetes and Docker Swarm become not just helpful, but really essential infrastructure.
Okay, that makes sense. And it's interesting because, as you said, both Kubernetes and Docker Swarm, they're fundamentally designed to solve that same core problem managing container clusters.
Right, the same goal.
But Angela's study really emphasizes that their approaches, maybe their underlying philosophies, are actually quite different.
They absolutely are. And understanding those core strengths, and maybe more importantly, their limitations, it isn't just some academic exercise.
No.
No, it's a critical decision point. For engineers, for DevOps pros, even for students working on scalable systems or cloud-native apps, the choice isn't purely technical. It really carries strategic implications for your team, your resources, and your project's future path.
Okay, good point. Let's dive into Kubernetes first then. The source often calls it the industry standard.
Common term for it.
We know it came out of Google. Now it's managed by the Cloud Native Computing Foundation, the CNCF.
Right.
For me, looking through the study, what really jumped out was the emphasis on its declarative configuration. That feels like more than just using a YAML file, isn't it?
Oh, it's a fundamental paradigm shift.
Yeah.
With declarative configuration typically using YAML, like you said, you're not giving Kubernetes a step-by-step list of how to deploy your app.
Okay, so what are you doing?
Instead, you define the desired state, what you want your application set up to look like, how many replicas, what resources it needs, ports, things like that.
The end goal.
Exactly. And then Kubernetes works tirelessly in the background to achieve and maintain that state, even if things break, like containers crash or nodes go down.
Okay.
This is incredibly powerful for stability and automation, especially in really complex systems.
That sounds like a huge benefit, that resilience layer. The report also highlights features like automatic load balancing and self-healing. How does it actually manage those, and why are they such, game changers for operations teams?
Well, take self-healing, for instance. Kubernetes is constantly monitoring the health of your application's components, your containers, your pods.
Right.
If a container crashes, or maybe a whole server it's running on fails, Kubernetes detects the drift from the desired state,
And
and it automatically replaces or restarts those failed components to bring the system back to that state you defined.
without you having to wake up at 3 a.m.
Hopefully. And you couple that with automatic load balancing, service discovery.
Yeah.
It means your applications can remain available and responsive, often with zero human intervention needed for those common failures.
Mm-hmm.
That's truly transformative for operational efficiency and, well, reliability.
Mm-hmm.
Peace of mind, almost.
Yeah, massive list of capabilities.
Yeah.
But Angela's analysis also points to a pretty significant catch.
Yes, and it's an important one to understand. The steeper learning curve.
Ah.
Kubernetes' immense power and flexibility, they come with a price, essentially. Increased complexity.
How so?
Well, it has a vast API surface, really nuanced architecture with lots of moving parts, control plane, nodes, etc., networking plugins.
Right.
It just requires a deeper understanding of its core concepts, its primitives.
So more upfront investment.
Exactly. This makes it generally more suitable for those large-scale production-grade deployments where you genuinely need those advanced features. And crucially, where the team has the bandwidth for that significant upfront investment in learning, setup, and ongoing management.
Okay. So if Kubernetes is the powerful, maybe complex, feature-rich giant, then the study makes a pretty compelling case for Docker Swarm as a sort of counterpoint. It's Docker's own native clustering tool,
That's right.
and the report often describes it as a more lightweight solution. How does Swarm offer a different philosophy for orchestration?
Swarm's philosophy is really rooted in simplicity and tight integration with the Docker ecosystem you likely already know.
Ah, so if you know Docker.
Yeah, if you're already comfortable with Docker commands, Docker service create, and so on, you'll feel right at home very quickly with Swarm.
Okay.
The study really emphasizes its quick setup and straightforward configuration. That translates directly into faster testing, faster prototyping.
Less initial headache?
Definitely. It provides the essential orchestration capabilities you usually need, like automatic service discovery, basic load balancing, rolling updates, but without all the extensive layers of abstraction and configuration options you find in Kubernetes.
That focus on efficiency and ease, it really comes through in the description. So for whom is this integrated, maybe simpler approach the ideal fit? Who should be looking at Swarm?
Well, the study suggests Swarm is best suited for small to medium-scale applications, places where you need to get container orchestration up and running quickly without taking on a huge operational overhead.
Right.
It's really perfect for rapid deployments, maybe development and testing environments, and especially learning scenarios. If you want to grasp core orchestration concepts without getting totally bogged down in intricate configurations first.
Makes sense. Like a gentler introduction.
Exactly. It offers a clear, accessible path, though it's fair to say it might not offer the same depth of really advanced features, like sophisticated auto-scaling or policy controls that Kubernetes provides for those very large, complex enterprise needs.
Okay. And what really helps, I found, in solidifying the difference is seeing them side by side, like the study does in that comparison table.
Oh, yeah, the table. That's super useful.
When you look at core things like complexity or installation time, the differences in their design philosophies just become crystal clear. Could you maybe quickly walk us through how they contrast on those key points?
Absolutely. That comparative table distills it beautifully. Let's get the highlights.
Okay.
First, complexity. Kubernetes is rated high. Docker Swarm is low. That reflects Kubernetes' extensible, sometimes daunting architecture versus Swarm's more opinionated, simpler design.
Big difference right there.
Huge. Then, installation time. Kubernetes setup is generally longer, more involved. Docker Swarm is quick and simple, often just a couple of commands. That directly impacts your time to first deployment.
Right, getting something running.
Scaling. Kubernetes offers sophisticated auto-scaling based on CPU, memory, custom metrics. Docker Swarm primarily relies on manual scaling, Docker Service Scale, although it supports basic scaling of services.
So less automation and Swarm scaling.
Generally, yes. GI support. Kubernetes has the official Kubernetes dashboard, plus many third-party options. Docker Swarm has no official native dashboard. You rely more on the CLI or third-party tools like Portainer.
Okay.
Community support. Kubernetes enjoys extensive, massive, rapidly growing support globally from vendors, users, the CNCF. Docker Swarm has moderate support, primarily driven by the Docker community itself, less widespread enterprise backing.
And finally, the big one, suitability.
Right. Kubernetes is geared towards enterprise-grade, complex systems, microservices at scale. Docker Swarm is positioned as ideal for small to mid-scale projects quick deployments, and learning environments.
That comparison really does paint a very clear picture. So let's bring it back to you, the listener. For someone trying to actually make a choice, what does this all mean for your project? When should you definitively lean one way versus the other, based on the study?
Okay, good question. If your project involves, say, large-scale enterprise applications, complex cloud-native microservices architectures, or if you anticipate needing really advanced features down the line, things like highly granular auto-scaling, sophisticated monitoring integrations, multi-node fault tolerance strategies, complex network policies.
Right, heavy-duty stuff.
Yeah, the heavy lifting. Then Kubernetes is the tool the study clearly recommends. It's designed for that kind of complexity and for long-term large-scale management. It's an investment, really, for future growth and extensibility.
Okay, so K8's for the big, complex, long-haul projects.
Generally, yes.
And then what about Swarm? For you listening, if you're maybe a beginner to orchestration entirely, or maybe your project involves simpler deployments, perhaps a smaller application, or if your main priority is faster testing and prototyping, maybe with limited resources or team expertise.
Then Docker Swarm offers a fantastic, really practical choice. It gets you up and running with orchestration benefits without that steep initial learning curve and operational complexity of Kubernetes.
So it's about matching the tool to the job.
Precisely. Choosing the right tool for the scope of the job you have now, while maybe keeping an eye on the future, but not over-engineering from day one if you don't need to.
What I also found particularly interesting about Angela's study is that it doesn't just focus on production environments.
Right. It branches out.
It specifically calls out this whole topic, Kubernetes versus Swarm, as being ideal for student assignments and research too.
That's a great point and very true. This subject matter is perfectly suited for, say, final year IT or computer science engineering projects.
How so?
Well, it provides really rich material for research papers focusing on DevOps or cloud computing comparisons. You can do comparative analysis presentations, and especially hands-on lab assignments.
Practical work.
Exactly. Students can create practical labs using tools like Minikube, which sets up a local single-node Kubernetes cluster easily, and then set up Docker Swarm, which is also simple to do locally. They can then deploy the same sample application to both, demonstrate the deployment processes, compare how resources are used, maybe even measure performance metrics like startup time or scaling speed.
That sounds like a fantastic learning experience.
It really is. It offers a very tangible, impactful way to learn that goes way beyond just theoretical knowledge. You actually build and compare them.
So as we start to wrap up this deep dive, the core message seems clear. Remember that the choice between Kubernetes and Docker Swarm, it really hinges on your specific project needs, your team's technical comfort level, and the operational complexity you're willing to manage.
Exactly. There's no single best answer here. It's all about finding the most appropriate tool for your specific context.
Right. Context is key.
Indeed. And maybe here's a provocative thought for you to consider as you mull this over. Beyond just the immediate deployment decision, how might that initial choice, picking between a high-complexity, feature-rich tool like Kubernetes versus a simpler, faster tool like Docker Swarm, how might that choice impact the long-term scalability or the maintenance burden, or even the kind of engineers you need to hire for your team as the project inevitably grows and evolves over time?
The downstream effects.
Exactly. It's a decision that can have echoes far down the line, well beyond just getting version 1 out the door.
That's a brilliant question to ponder. Really makes you think about the bigger picture. We definitely encourage you to continue exploring these tools.
Yeah, definitely.
Perhaps even, like you suggested, trying them out in a lab environment, getting your hands dirty, just as Angela's study suggests.
That's often the best way to really solidify this kind of knowledge. You have to play with it.